No. I'd be glad to show it to you, and what you're gonna see is that every third one is underlined, and then there's gonna be a number at the top,
I would love to see it.
okay?
Just to clarify, the test, tomorrow is 4, 5, 6.
Yes.
And then the test that's gonna be on the 9th is gonna be 7 and 8,
And whatever,
and whatever else gets stacked up.
yes.
Oh, we're trying to squeeze everything in.
Do we know if we're gonna finish the course?
Well, we're finishing that day regardless
The
of,
10th, is that the last day before?
are we gonna cover all the material possible? No, there's not enough time. That's the reality of it.
The
There's not
last-
enough time, even in a 16 weeks, to cover really all the material. Unless I just want to do a drive-by, hey, here's the equation, all right, next.
Yeah. So what's gonna be on the majority of the test tomorrow, like the facades and the force diagrams and stuff like that?
Yeah,
Okay.
if you look at the old tests, test 1B, or half of test 1, it's that stuff.
Do you have the answer keys for the test 1Bs? Because you only have one answer key for one test, and the rest don't have their answer keys.
Okay,
I think most of them have answer keys.
The test 1Bs they're missing theirs, the blank one and the 2018-2019.
I thought there was 2 that I checked.
what's posted is posted, I don't remember actually. Because those tests that I posted, it's been a while ago.
Could we do one test level problem from each chapter, so 4, 5, 6? Could we go over like one test level?
Does this count for 6?
Yeah.
So it's, okay.
Kind of.
I mean,
Just
you
do one
tell
for-
us,
yeah.
does this match your test level question tomorrow?
I have asked test questions like this on the test.
But
You would want us to find more than just what we
Yeah.
arrived at though, yeah, like on the test, like you would want us to find.
What I did on this particular question where I had something spinning around was part A, draw the force diagram. Part B, what are the equations of motion?
Oh.
Part C, what is the angle?
is that the short answer question or just like the beginning question?
That was under the short answers, not the formal.
Okay. Could we do one for 4 and one for 5? I've officially moved to the wrong side of the list, haven't I?
I would rather you have a specific one you would like me to work on,
Okay.
Can we have like a?
but this is the reason why I don't write the test till the last minute.
I would like a.
Could we do,
There's
can we do one that's kind of like several objects on something and we're dealing with friction
What if?
and either a pulley or.
Oh, like what if you had like a triangle, and then there's like a pulley pulling on another triangle with a box on top, and then the same one for the other side, looking for the angle. I think that's like a
Would somebody
very complex
equivalent
test.
to number 7 on the master set be on the test?
Well, the master set problems are all test problems,
Okay,
so
I figured, but I figured I'd ask anyway.
I feel bad for everyone have to go through that.
So you want a complex, multifaceted,
Yeah.
Like like a triangle.
Yeah, something where we definitely have to decompose something.
Yeah.
And we have to account for friction, I guess.
Yeah, and then it's not like it's easy to decompose like things on a box, but things on the triangle is a lot harder.
Yeah, I agree.
the acceleration of the system.
Two quick questions, does that say 6 meters, the length of the ramp?
Yes.
And then what is all on the left? All the way to the left?
It's 0.5 meters.
Okay. So you're
I'm gonna change this 6 here to 7 kilograms.
Is the rope frictionless as well?
Pardon?
Is the rope frictionless?
It's ideal.
Okay.
Yes. All right. Begin. Yes.
Should we know what the angle is from the rope to the ground? Or should we find that out?
Find it out. That's why I gave you all those measurements. All right, so, first step. Yep. I really only care about the two masses. So I've got the 7 and I've got the 4.
Weight acting down on both of them.
Say it again.
Weight acting downward on both of them.
All right. So W7, W4. Okay.
tension that way for 7, and then up for 4. Normal force up for 7.
Up for 7.
Did you say it was friction?
Oh, yeah, let's throw friction into it. Let's just assume it will slide, so okay, equals points. All right.
Friction acting.
So friction, done, tension, done, other, none. Normal force, done, gravitational force, done. All right, we got a force diagram.
Is the 0.5, is that the length from the ground to the rope or length of?
From the ground to where the rope's attached to the box.
Alright, perfect.
Decomposition?
After force diagram,
Oh,
Equations. Oh,
acceleration and
coordinate system.
coordinate system.
all right, so which way is box 4 going to accelerate?
Going down.
Which way is box 7 going to accelerate?
To the right.
So this is going to accelerate down, that's going to accelerate that way.
So, to find the direction of the acceleration, you just basically use your common sense.
Yes.
Just wondering if there's any other way.
You would keep it generic. You would establish, say, for lack of a better subscript, AX, AY for 7, and then AY for 4. And so you'd have two components of acceleration acting on that box. Coordinate axes.
We're the same coordinate axis for both.
Yep. If I heard you correctly.
Then to the right. Or J high.
I had 7.
Yeah.
Did you guys use the same vermouth or we need one for both?
Can
In this particular case, yep, because those accelerations are perpendicular to each other, you can, but you don't have to. So did you want to use the same system for both?
Sure, why not?
Okay. Up,
Let's put J.
All right,
do you want?
we could do up J hat, absolutely no problem, just be careful that the acceleration of this one would be a negative A,
Okay.
which is fine,
Yeah, why not?
so up.
Yeah.
All right, the people who spoke decided they wanted same coordinate system for both of them, sure. So once we have our coordinate axes, decomposition. All right, so this gets into a tricky spot about how do you, first off, what do we decompose?
We're decomposing the tension at the 7 kilogram box.
So what is the angle?
We had to find.
Yes, we do.
Just has tension.
So I know it's traveling like that, I have some distance here of 0.5 meters. The distance from here to the beginning of the ramp is 2 meters. And this distance here is 6 meters with an angle of 30 degrees. Ultimately, I need to figure out the angle, I need to figure out how far over, how far up. In other words, I need to know that and that. And go. In essence, this is a vector addition problem. If I'm using that convention over there, it's 0.5 meters, negative 0.5 meters j hat, plus 2 meters I hat, plus 30 degrees. This is the problem we're working with here. So if I'm adding rectangular and polar forms, how do you do it? How do you want to do it?
Convert that,
That's it.
You said the same thing?
yeah, convert that into rectangular form.
All right. So, in other words, how far over, how far up does this one go? So this is 6 times the cosine of 30 degrees, and this would be 6 times the sine of 30 degrees, which is 3. And that one, I don't know.
Isn't that, so the 2, isn't that just going to be like I hat to I hat? Because it's just moving, never mind actually.
What is this?
5.196.
So I have negative 0.5 j hat plus 2 I hat plus 5.696. 696 I hat plus 3 j hat. So in essence, I'm going over 7.696 to the right.
It's 5.196.
That's 196? Okay.
That was
No, you said it right. I think you misheard.
Yeah, I couldn't read my handwriting. So 7.1, nope, I erased the wrong one. All right. So 7.196 meters to the right, and then up is 2.5 meters up. Ultimately, I just need the angle. I don't need to know the length of that rope, but I can find the length. But I need to figure out the angle. So this is 7.196, and this is 2.5. And I need to figure that out. Pardon? That, or arctangent. So the angle is the arctangent of 2.5 over 7.196, which is something this right here?
Oh, that's just what's in the parentheses, yeah.
Okay,
19.158.
That's fine.
thank you. All right, so we now know what that angle is here. When we break this up, I will call this theta sub t. And we know that's 19.1. So how's the tension get broken up?
So ft cosine goes to the right,
Alright.
and then sine ft sine theta goes up.
Okay, we've decomposed the one vector we need to decompose. Now, equations of motion. All right, questions before we do equations of motion? Jackie, you still, I was gonna go to the next screen. All right. How many equations of motion will we have?
3.
Yes. If you wanted a fourth one, there'd be 2 for this one. If you wanted 2 for this one of the equations would be 0 equals 0. Which is a valid equation and a true statement, but not particularly helpful. All right, so what are my 3 equations of motion?
I have
The first box.
Okay.
I had, you have, FT cosine theta t minus friction equals MK. Yes. Those are the only ones going in that direction, so that should
Yeah.
be right.
Which one?
For I had of the big box.
This,
Box
we
7.
forgot friction.
We do.
There's one small mistake, which you might catch on your own without, I mean, you might have mislabeled it here and then correct it later on.
Okay.
Okay, not the one I was thinking of. That's not the crucial one at the moment.
Acceleration is negative root.
No, acceleration is in the I had direction. What did you say?
I was saying it'd be negative, but,
No, the acceleration is positive. It would be going to the right because we're doing the 7 kilogram mass. It's the fact that it's the 7 kilogram mass.
Oh,
And again, I've had students leave it blank there and then later on correct it. And other students will leave it blank just as an M there, and the other one's an M, and at some point just sort of say, well, they're the same. And they make it either 7 or 4 or 11 or 23 for some reason. All right, 1 down, 2 to go.
Normal force plus FT sine theta t minus weight of 7 equals 0.
And other people could play, you don't have to let Word do it all.
Yeah.
Or you could let Word do it all, you just enjoy watching her struggle.
and then,
Or
go ahead.
you go.
Alright.
I'm still processing.
So it's just, it's in our diagram, it's Ft minus weight 4 is equal to M4A.
What's the problem?
Negative,
The acceleration, if it accelerates this downwards. So the magnitude is A downwards, but we chose up positive, so it is negative A.
Okay.
And that's the thing you have to keep in mind if you're choosing a direction of your coordinate system that's opposite the acceleration.
Just to make sure, I can make a different coordinate system for the
Yes.
different box, okay?
Yes.